Right now, the universe is incredibly loud and hyperactive. It's packed full of burning stars, orbiting planets, and complex biology, all moving constantly. But that dynamic activity comes at a heavy cost. Every single process requires massive amounts of energy to keep going. We look up at the night sky and it feels perfectly stable, but that permanence is an illusion. The universe is actually locked in a massive, silent tug-of-war. On one side, expansion pushes everything apart. On the other, gravity tries to pull it all together. And in the background, thermodynamics slowly drains the available energy. Because of this ongoing battle, the universe has a definitive expiration date. The end of reality isn't a random lottery. It is a strict mathematical outcome determined entirely by which of these fundamental forces ultimately overpowers the rest. According to physicists, the current frontrunner to win this tug-of-war is thermodynamics. Specifically, the second law of thermodynamics, which states that entropy always increases, meaning energy always spreads out. As stars burn through their fuel, their highly concentrated energy moves from hot focal points out into the cold emptiness of space. And crucially, that energy never naturally moves the other way. It cannot be recycled. This diagram shows the big freeze. New stars stop forming, existing ones die. Black holes leak energy via Hawking radiation until they fade to black. The universe reaches barely above absolute zero. Zooming to the atomic level, protons decay. Solid matter breaks down into drifting radiation. Because nothing is hotter or more energetic than anything else, equilibrium is reached. Nothing can happen. No processes can run. But there is a strange quantum loophole here. Over an infinite amount of time, in an entirely dead universe, quantum mechanics won't allow things to remain completely still. Random fluctuations will occasionally occur. Give those rare random fluctuations an infinite number of attempts, and eventually they will assemble highly complex structures. Physicists call the most extreme version of this a Boltzmann brain, a fully conscious mind, complete with false memories, that spontaneously blinks into existence out of the void, only to dissolve moments later. If entropy wins, physical reality quietly starves to death, leaving behind a dark expanse where randomly generated fleeting moments of consciousness actually outnumber real biological life. Right now, there is an invisible force actively pushing the universe apart, causing it to expand faster and faster every second. Scientists call it dark energy. Currently, dark energy is losing the localized battle against gravity, as galaxies and solar systems firmly hold their shape. But that changes entirely if we introduce phantom energy, a theoretical variant of dark energy that grows stronger as the universe expands. This diagram illustrates the Big Rip. If phantom energy is real, its outward push eventually overpowers every force holding matter together. It systematically tears apart galaxies, then solar systems, and then planets. In the final second, the bonds keeping atoms together fail. Protons and electrons are stripped away, and space itself stretches to infinity in a single violent moment. There is an even stranger variation of this called the Big Snap. This scenario assumes that the fabric of space isn't perfectly smooth, but is actually made of microscopic, granular pieces. Just like stretching a rubber band too far, relentless expansion would eventually put too much pressure on those tiny pieces of space, physically cracking the structure of reality. A dark energy victory ends in total aggressive destruction, leaving a void where the rules of math and physics completely stop functioning. But what if dark energy eventually loses its momentum? If the expansion slows down or reverses, gravity takes the steering wheel, pulling all cosmic material backward. This is the big crunch. As all the matter in the universe rushes back toward a center, the total volume of space shrinks. The leftover ambient heat from the Big Bang is forcefully squeezed into a tighter and tighter area, rapidly driving up background temperatures. Soon, the empty space between stars becomes hotter than the surfaces of the stars themselves. Unable to vent their own heat, stars and planets soak up the surrounding energy, swell, and melt entirely into a universal plasma. As the crush accelerates, every piece of matter that has ever existed is violently compressed into a single microscopic point of infinite density, a singularity. However, the collapse might not be the final step. The Big Bounce theory suggests that this ultimate compression could act like a tightly coiled spring, instantly rebounding to spark a brand new Big Bang. A gravity victory is unique among the apocalypse scenarios. It is the only outcome that completely destroys the current universe, while physically paving the way for a new one to begin. There is one scenario that doesn't rely on expansion or gravity. It is an immediate, unpredictable threat, hiding in a fundamental flaw in the rules of reality itself. To understand it, you need to look at the Higgs field. This is an omnipresent, invisible field that assigns mass to particles. Without it, atoms couldn't form, and physical matter would be impossible. Looking at this graph, the Higgs field appears stable in a shallow dip, but it might be in a false vacuum, far above its true baseline. Through quantum tunneling, it could spontaneously drop to the absolute bottom. This triggers vacuum decay, spawning a bubble of altered physics. Inside that bubble, the laws that govern atoms no longer apply. Because the bubble expands outward at the exact speed of light, it would completely rewrite our physical matter before the light of the event ever reached our eyes to warn us. Theoretically, a highly advanced civilization experimenting with extreme space manipulation could even trigger this localized vacuum decay entirely by accident. A quantum failure offers no slow fade and no dramatic crush. It is simply a blind, instantaneous deletion of reality as we understand it. Whether it happens through a slow freeze, a violent tear, a fiery crush, or a quantum erasure, the physical universe is mathematically guaranteed to expire. Right now, our observational data and mathematical tools simply aren't precise enough to definitively declare which force will win the tug-of-war. But barring a random quantum bubble erasing us this afternoon, these apocalypse scenarios require billions or trillions of years to unfold. The inevitability of the end is precisely what gives the present its value. We exist in a microscopic, wildly improbable window of cosmic balance. We are living in an era just stable enough to allow for stars, for life, and for the consciousness required to look up at the dark and wonder how it all finishes.